All right, guys, tonight we're going to finish up Unit 3, I'm sorry, with memory. So last week and the week before, we looked at classical conditioning and operant conditioning types of learning. This week we're going to finish up with memory because there's no point having the ability to learn if you don't have the ability to commit what you've learned to memory. And there's no point having a memory system if you don't have the ability to learn. So let's get started with memory encoding. Here we go. So memory depends on the sequential processes of encoding, storage, and retrieval. These processes have been compared to the elements of an information processing system like a computer. Think about what a computer has to do. It has to get the information in, you have to be able to hold on to it, and then you have to be able to get it out when you need it. Encoding, getting it in, storage, holding on to it, and retrieval, getting it out again. So if we look, the encoding process involves forming a memory code. Like with a computer, you sort of get the information in by using a keyboard to enter the data. Storage involves the maintenance of that encoded information, especially over time. Again, it can be sort of compared to saving information on a computer's hard drive. Although the memories that we have tend not to be exact copies, like when you save a document to a hard drive on a computer, you're saving an exact copy of it. Our memory doesn't work that way. And finally, retrieval. So retrieval involves taking the information from the memory storage system and getting it out again. So if you were using a computer, when you open a file and look at the information on the file, that would be an example of retrieval in the memory process. Okay. So if you look here, although people tend to equate memory with storage, it's sometimes hard to overestimate the importance of encoding. So if you look at this demonstration and you look at these pennies, I'm sure everybody has seen pennies, Which drawing do you think is the real penny? And most people have a difficult time with this because even though they know what a penny looks like, they never actually encoded the actual details of a penny because they don't have to. So a lot of people, if I give them the same example, tend to get it wrong. So let's say this one. That is incorrect. So let's take a look at the one it is, and it's actually this one. So if you got this one right, good job. If you got it wrong, don't feel bad. Most people do. Okay, here we go. All right. So the question is, why do most of us have a poor memory of a thing like a penny, something we see every day? It's usually because encoding requires attention, and most people don't pay much attention to the appearance of a penny. They know, like I said, basically what a penny looks like, but they never actually pay attention to the details of it. So, for instance, if you've ever been introduced to someone and then realized only 30 seconds into your interaction with them, you've forgotten their name already, the reason is you never really tried to encode it in the first place. Probably wasn't important enough for you to try to remember it. So as a result, if you don't pay attention to it, you tend to forget it. All right, let's take a look at another concept called levels of processing theory in memory. So encoding is critical to memory. However, according to two researchers, Fergus Craig and Robert Lockhart, not all encoding is created equal. Some methods of encoding create more durable memory codes than others, meaning there's better ways to get information into memory. So let's take a look at those different ways. So you could process information shallow, intermediate, or deep. We're going to talk about each one of those. So, for instance, in dealing with verbal information, people can engage in three progressively deeper levels of processing: structural encoding, phonemic encoding, and semantic encoding. So I'm going to click on each one of those to give you a better sense of what each one means. So the first one is structural encoding. So structural encoding emphasizes the physical structure. And this is a relatively shallow processing that emphasizes the way the word looks, such as whether or not it's printed in capital letters or how many letters it contains. Then we go to phonemic encoding. Phonemic encoding is an intermediate level of processing that emphasizes what a word sounds like. And then finally, deep processing, which is the deepest form of processing that emphasizes the meaning of the verbal word, the meaning of the word, not the way it looks, not the way it sounds, but what it means. That tends to give you the best memory for the word. So, levels of processing theory proposes that deeper levels of processing result in longer lasting memory codes. In one test, the researchers manipulated subjects' processing. They briefly presented stimulus words and then asked the subjects questions about the words that were designed to induce structural, phonemic, or semantic encoding. So I'm going to click on the type of encoding to see an example of a question that would induce it. So structural encoding is the word written in capital letters. Phonemic encoding, does the word rhyme with weight? And finally, semantic encoding, would the word fit in the sentence, he met a blank on the street? So all of this was designed to sort of put in place different levels of encoding. After responding to 60 words, this is the research, the subjects received an unexpected test of their memory of those words. The subject's recall was low after structural encoding, notably better after the phonemic encoding, and highest after semantic encoding. So as predicted, deeper processing led to better memory. All right, let's take a look. Make sure we understand this before we move on. So, does the word have more than 6 letters? Should the word fit in the sentence below? When words are presented to subjects, they're asked one of two questions shown here that should elicit different types of encoding. So I'm going to click on each one, and we'll take a look. Yes. So when words are presented to subjects, they're asked one of the two types of questions shown here, which should elicit types of encoding. And then I'm going to show you the one that induces the deeper processing. Again, does the word have more than 6 letters? Does the worm ride with cat? Deeper processing. Okay. Now we're going to look at encoding with visual images. So when it comes to forming memory codes, structural, phonemic, and semantic encoding do not exhaust the options. For example, you can also encode words by creating visual images to represent the words to be remembered. Of course, concrete words such as juggler are easier to create images of than abstract words such as truth. The beneficial effect of visual imagery on memory was demonstrated in another study by a guy named Alan Pavio and some of his colleagues. Excuse me. They asked subjects to learn a list of 16 word pairs like these, then manipulated whether the words were concrete, high imagery words, or abstract, low imagery words. As the data of the research show, the best recall occurred when 2 high imagery words were paired, and the worst recall was observed when 2 low imagery words were paired. According to Pavio, imagery facilitates memory because it provides a second kind of memory code, and believe it or not, 2 codes are better than 1. And we're going to look also at something called a mnemonic device. So many popular mnemonic devices depend on visual imagery, including the link method and the method of loci. We're going to talk about each of these 2 mnemonic devices. The link method involves forming a mental image of items to be remembered in a way that links them together. So for instance, suppose you need to remember a list of items to pick up at the drugstore. A news magazine, shaving cream, back in the day, film for your camera. To remember these items, you might visualize a public figure on a magazine cover with a camera around his neck, pen sticking out of his ears, and shaving cream on his head. So, in a sense, by creating a visual image of the things that you're trying to remember, it makes it easier to remember those things. That's called the link method. Then, the method of loci involves taking an imaginary walk along a familiar path where images of items that you need to remember are associated with certain locations. So, the first step is to commit to memory a series of what we call loci, or places along a path. Usually, these loci are specific locations in your home or neighborhood. So, think about your house. Walk through your house in your mind and think of different locations in your house. Then, if you were sort of trying to remember to pick up like hot dogs or cat food, tomatoes, bananas, and whiskey, your loci might be your driveway, your garage, your front door, your closet, and your kitchen. So, in a sense, what you're doing in order to remember those individual items is you're associating each of those individual items with a different part of your house. So, what you're doing is forming distinctive, vivid images of the one thing you want to remember in each one of these locations. When you need to remember the items, you imagine yourself walking along the path. The various loci on your path should serve as retrieval cues for the images that you formed. So, it helps in remembering those items. Okay, that ends video number 1 on memory.